Alright, so this is the practice test for section 64268. And you can see this is kind of long this time. So this is a longer test than we've normally had. There's only 20 problems. I mean, it's just the graphing takes up a lot of space. So that's one of the things that people always think, oh, this is so huge. It's longer than what we've had. It's not just one piece of paper front and back. But we're going to take 2 days to go through this. And we are going to start right here with 1 through 6 where it just says simplify each expression. Assume that all variables are positive. And I see I have 343x to the 6th, y to the 12th, over 64x to the 3rd, y to the 6th. And I'm supposed to raise that to the 1/3 power. You remember this stuff? Can we try and remember what 1/3 power does? When you grow a plant, where are the roots? On the bottom. So what root is this really supposed to be? Cubed root. Yeah. So if it makes it easier, you could do this. But I think it might be easier if you think of cubed root for the numbers, but not necessarily for the variables with the exponents, because the cubed root of 343 might be something nice that we can find, and the cubed root of 64 might be something that we can find. But I notice, hey, the x's and the y's aren't even simplified yet. So I probably want to do that before I think about the rest of it. So x to the 6th over x to the 3rd, what would that give us? X to the 3rd, because we subtract. And then y to the 12th over y to the 6th. Y to the 6th, because we subtract. And now the reason I said I might just leave that 1/3 is because isn't 3 times 1/3 something nice? Yeah, it's 1. How about 6 times 1/3? What's that? It's 2. So using the properties of exponents for these back here might make that go a little bit faster. But some of you were really good at cubed root when we did that on the last test, so maybe cubed root was great for you there. Did you already look up the cubed root of 343? 7? How about the cubed root of 64? And there we are, 7/4 xy squared. Beautiful. So whether or not you want to use cubed root for the whole thing, or you want to go ahead and use what I did here with power to a power being multiply, you're going to get the same answer. You just have to be careful. That's all. Alrighty, so taking a look at number 2, negative 128 to the negative 3/7. What you thinking? So 7th root. Let's try that. And let's hope that's something nice, right? 7th root of negative 128. Not just 2, though. Good, negative 2. What is negative 2 times negative 2 times negative 2? Negative 8. There we are. Yeah, Jackson. Oh, I didn't see the negative. Thank you. I got my cheaters on, and so sometimes I'm going up and down like this. I didn't see it. Thank you. So it's not negative 8, because we still have to deal with the negative 1 power. Where's it go? It did. So help him out. What does that mean we have to do with it? Put it on the bottom of a fraction. Now, you could do negative 1 over 8. You could do 1 over negative 8. Negative 1/8. It doesn't make any difference as long as you only have one negative on there. So that negative power has to bring us down to a fraction. Bring it down to the bottom. Take the reciprocal. That's what negative powers are for. Thank you, Jackson. I did not see that negative up there. Alrighty, looking at 3. That's definitely different, right? It is and it isn't. First off, I think they're messing with us a little bit. I think one of those is reducible. Yeah. They were hoping we'd miss that. Now, when we want to multiply similar bases, what are we supposed to do with the exponents? Add them. We can't add those two because they don't have the same denominator. Unless you use your calculator, and then you absolutely could add them, hit math number 1, and boom, the fraction will come out. But if I wanted to do this by hand, I have to have a common denominator. What's the least common denominator for 1/6 and 1/4? 12. So this one would need to be multiplied by 2 on the top and the bottom, and this one by 3 on the top and the bottom. Now, can we add them? Yes, we can. And what would we get? 5/12. Anything else to do with that one? Done. Came with fraction powers. We're leaving it with fraction powers. That's important. Alrighty. Number 4. I'm not going to miss this negative this time. Thoughts? You want to do cubed root? Okay, so Jackson is separating this and saying, wouldn't we want to do cubed root of 27 to the negative 1, but then power to a power, what do you do with the x negative 3y to the 6th when you raise a power to a power? We have totally forgotten. If we don't want to use cubed root, and we want to raise these to this power, we multiply. So negative 3 times negative 1/3 would be x to the 1st. And then we'd have y to the negative 2. Now, do we know what the cubed root of 27 is? It's 3. And I don't think that's done. What do we need to do? All of them down to the bottom? No, just the what? The 3 and the y term. So x is going to stay right up there because that's a positive 1 power that we had for the x. Well, that's kind of pretty. Right there. Now, could you do it with cubed root? Yes, you could. You could go through and say the whole thing is the cubed root, and then at the very end, flip it just like we did on number 2 up there. You absolutely could do that. So either way, whatever is easiest for you to understand is what I want you to use. Ooh, look at 5. Yeah, what you got? Negative 3 times negative 1/3, positive 1. 6 times negative 1/3, negative 2. So it's all about the multiplication. Negative times a negative is a positive. Right?
Wait, so why did we keep the negative 1 up on the second one, but then this one is a positive 1? Because on the first problem, when we did negative 8 and negative 1, we had a negative 1 up there. So why is
Oh, see, Grace, this negative can go anywhere, but I just have to use it once. So it could go on the top, it could go on the bottom, it could go in the front of the whole thing, like that. It doesn't matter where it goes, but we have to have it there. Have to have the negative. Good questions. 5 looks yucky. So, can we do division of a cubed root and a 4th root? No, but test-taking strategy. All the other ones had fraction powers. So, maybe if I write this as 6 to the something over 6 to the something, then maybe I can do it. Cubed root is what for the something? 1/3. Roots go on the bottom. They grow in the dirt. 4th root. 1/4. Now we might be able to do something. What do you do with the exponents when you're supposed to divide? Subtract. This is subtract. So problem. We need another common denominator, unless you're going to use your graphing calculator. If you use your graphing calculator, you won't have to do the common denominator thing. Everybody knows how to do that math fraction button, right? So let's just say at this point you're like, I don't want to mess with the fractions. So I'm going to take parentheses 1 divided by 3 minus parentheses 1 divided by 4, get a nasty decimal and hit math number 1, enter. Oh, look at that, it's 1/12. Then you wouldn't have to do the math in your noggin. But then you better be sure you're right, because you haven't shown any work, if you do that. So instead, I would do 6 to the least common denominator for 3 and 4 is 12. So this would be multiplied by 4 on the top and the bottom, 4/12 over 6 to the 1/4. We'd multiply by 3 on the top and the bottom. We get the same answer. It's just that if you were to, well, my big fingers hit the wrong buttons every once in a while and I mess something up, then you don't have this little extra step to get points for, because all I can see is the final answer there. 6 to the 1/12. Now, another problem. Did the original come with fraction exponents? Then we should not give a fraction exponent answer. We should give a root answer. But 1/12 is what root? Ew. Turns out we don't care because it's right. Okay, so what if it's 12th root? It's correct. There it is. Got it. So, number 6. Thoughts? You can do that first. However, I see some things in the parentheses. Do you see? You could make it much easier, couldn't you? So if you're going to do division in the parentheses, what are you supposed to do with those powers? Subtract. So what's 2 minus a negative 8? 2 plus 8. Ooh. And now we could just multiply those because it's a power to a power. So top times top, Danny. 2 minus a negative 8 will become 2 plus 8 because the 2 negatives make a positive. Yeah. All right. So now, like I said, we'd multiply. And that you could do on your calculator, or you could put a 1 underneath there and do top times top, bottom times bottom, and then divide. 25ths will get you 4. X to the 4th. Done. So when your things are going through your head about all the things you could do, and you're like, oh my gosh, there's 3 different things I could do here, think order of operations, parentheses first. Jackson. The 10 times 2/5? Yeah. Yeah, you absolutely could. Blammo. No more thinking. Yeah. As long as you use parentheses for your fractions, the calculator will always work that through for you. Yeah. So far, so good? Yeah, when you first looked at it, and I asked you guys if you remembered all that, you're like, no, I don't remember any of that, but it's coming back. It's coming. Ooh, solve each equation. Check for extraneous solutions. So, do you remember how? You do so. How do you undo square root? You square both sides. And that's because the square root is already by itself over here, so we'll just square both sides. So this will be x plus 2, but this is going to be kind of obnoxious because it's x minus 18 times x minus 18. Yuck. All right. Well, we do the FOIL. x squared, negative 18x, and negative 18x is negative 36x. 18 times 18, most people do not memorize past 15 times 15, 324. We're not done. Thoughts? We need a 0 on one side. Yeah, we're going to have to try and factor that big dog. Let's see. So we've got x squared minus 37x plus 322. Ew. All right, 322, huh? So we need two numbers that multiply to 322 and add to negative 37? Okay, well, 322 divided by 2, 161 and 2 are not going to add to 37. How about divided by 3? No, that's not nice. 4. That's not nice. 5 isn't going to work, right? 6. 7. Getting closer. Nope. Nope. Obviously 10 isn't going to work. Oops. Ooh. 14 and 23. Took a while, didn't it? 13 and 23, add to 37. So two solutions. What and what? 14 and 23. But maybe, just maybe, they don't both work. Remember, these are the ones where we have to check. So, let's see. I didn't leave myself a lot of space for checking, did I? Move this down a little bit. Alrighty, so the original said the square root of, and we'd be putting 14 plus 2 in there, equals 14 minus 18. Okay, well, 14 plus 2 is 16. Square root of 16 is 4. Uh-oh. What do we get on the right-hand side? Negative 4. 14 was extraneous. Let's try 23, see if that one works. Square root of 23 plus 2 equals 23 minus 18. 23 plus 2 is 25. The square root of 25 is 5. Oh, that one works. That one's good. So with square roots especially, we have to check. We absolutely have to check. So I want you to look at problem number 8. Should we solve that a brand new, totally different way? What's 1/2 power the same as? It's square root. Now, you remember way back when we actually did this section, they said, what you want to do is raise it to the reciprocal power. Well, that would be a 2 anyway. So we'd get 2x plus 1 equals 25. Well, that's not as hard to solve as this last one, is it? What do we do? Divide by 2? Okay, but here's what I know. When you raise stuff to an even power, sometimes you get answers that don't work. So I definitely check it and say, is 2 times 12 plus 1, when you raise that to the 1/2 power, is that negative 5? It's not, is it? It's not. That's the only answer we had. And it didn't work. So what are we supposed to say? No real solutions. Isn't going to happen. no real solutions. We got an answer, but our answer was extraneous. So nothing works apparently. Now, I would certainly, if that's on the test, I would verify that with my graphing calculator. I would make absolutely certain that those two graphs are never going to hit each other. So I would do parentheses 2x plus 1 parentheses to the parentheses 1/2 power. And then I'd put -5 on the other side and try zoom 6, but if I see anything that looks like it's going to make them hit, can everybody see there's no way that that's ever going to get down there? Our graph was going to the right forever and it's going up. There's no way it's going to hit. Now I would know, okay, now I can put that down on a test. Because on a test, usually the problems work. You know, we want to see whether or not you can actually get the answer. It's not going to happen. Alrighty. 9 is definitely a different problem. What do you suppose we should do there? Cube them both. Yeah, raise them both to the 3rd power. I'm going to leave that so when we go to check later we can see it. Well, it's nice on the left. It's going to be 2x minus 4. -2 times -2 times -2. -8. Next step. Add 4. So 2x equals -4. Then divide by 2. X equals -2. But we have been taught, especially, well, if you go way back up at the top, it says, check for extraneous solutions. Now this one I'm not too scared of. It's even powers that tend to give you wrong answers, but we'd still want to check because it said to. So cubed root of 2 times -2 minus 4 equals -2. Well, 2 times -2 is -4, and -4 minus 4 is -8. Is the cubed root of -8 -2? Yes, absolutely. Checks. It's good. X equals -2. Uh-oh. 10 must have an extra step. Ideas? I can't do that yet. There's a nasty little 2 in the front. No, don't distribute. You can't do that. Remember, order of operations says you have to do powers first and then multiplication. I want the 2 gone. Divide both sides by 2. I don't want that there. It's making the problem harder. I don't need my problems harder. Now, we have to raise it to the reciprocal power. So we're going to have to raise both sides to the 3/2 power. Now, why is that a big deal? When there's a 2 on the bottom, what does that mean it really is? Cynthia? Okay. Because 2/3 times 3/2 is 1. And we want that 1 right there. If there's a 2 on the bottom of the fraction, what root is that? That's square root. Whenever we write down a square root, what do we always have to do? Plus or minus. This could be positive, but it could be negative. So let's figure out what it is and then put a plus or minus piece in there. This is going to be x minus 2 over here. That's great. That's much easier. But over here, if we take the square root, it could be positive or -5. And we're going to have to cube that. So what we're doing is we're taking the square root of 25, and then we're going to cube it. Okay, so what's 5 cubed? Use your power chart if you need to. 5 cubed? 125. What's -5 cubed? -125. So we're going to need 2 equations for this one. We're going to need x minus 2 equals 125 and x minus 2 equals -125. Now in the notes, when I was gone, the notes use absolute value because that's what the book says to use. If you're going to take a square root like this, it says slap some absolute value bars on there. But what I found is because you only use absolute value bars for those very rare problems where there's an even number on the bottom, people forget to do that. So instead, I want you to think, when I take the square root, because of this 2 on the bottom, I need to have a plus or minus. Now we're almost done, because now all we have to do is add 2 all over the place. So x might be 127, and x might be a negative 123. I gotta check. So let's see. Maybe they both work. I don't have a lot of room for checking here. I wrote too big. So we would have 2 times 127 minus 2 to the 2/3 equals 50. Okay. Well, 127 minus 2 is 125. I'm going to have to move this up. Nobody's going to be able to see it. Now, which of those is the root in that fraction power? 3. So it's 2 times the cubed root of 125 squared. What's the cubed root of 125? 5. So it's 2 times 5 squared. I'm writing too fast for the smartboard today. What's 5 squared? Is 2 times 25 equal to 50? Excellent. At least our first one works. This one's good. X equals 127. And maybe, just maybe, the other one works too. Let's check it out. So that would be 2 times negative 123 minus 2 to the 2/3 equals 50. Well, that's negative 125 to the 2/3 equals 50. So we'll have the cubed root of negative 125 squared equals 50. What's the cubed root of negative 125? Negative 5 squared equals 50. What's negative 5 squared? Still just 25. Hey, they both work. Excellent. They're both a go. So this one has 2 answers. All right. Now we're down to the bottom of that page, aren't we? If anybody misses anything on this test, it's this right here, the negative 125 and the positive 125. Because absolute value, we covered that in the first 3 sections, and it's like it just totally leaves your mind. Add to that the fact that several of you did not do that assignment because I was gone and you took a mini vacation, and now we have big troubles. So maybe circle, star that one, give it a little more time. Let's see. Let f of x equal x squared minus 3 and g of x equal x plus 4. Perform each function operation and then find the domain. I remember these. We actually need to talk about domain right away. Otherwise we might miss something. So what are the 2 things that cause us to restrict the domain? Negatives. If it's a power. No, kind of. You're on the right line. You're thinking about the numbers there. Fractions. We can't divide by 0. Either one of these have fractions. Okay, so we don't have to worry about fractions. What's that other thing though, folks? Square roots, 4th roots, 6th roots. Do you see any even roots up here? That's good news. That means the domain of f is all reals, and the domain of g is all reals. There's only 2 things we look for. Even roots, square roots, 4th roots, 6th roots, 8th roots, and division. And I see that 11 is going to be a problem right away because it tells us to divide. So let's see what we have. x squared minus 3 over x plus 4. We just created a number that cannot be used. Negative 4, yep, because x plus 4 would be 0. So negative 4 is out. Now we might not be done, and that would be if we can factor x squared minus 4, x squared minus 4, x squared minus 3, and somehow cancel that with x plus 4. X squared minus 3. Well, it's not a perfect square, right? Because 3 is not a perfect square. Are there two numbers that multiply to negative 3 and add to 0? Then we're done. That was all we could do, was put f of x over the top of g of x and talk about the domain. That's kind of messy. I want to make sure people that are gone can read that. There we are. So that was all we could do, because we can't factor x squared minus 3. This one is subtraction, so let's see what we've got here. F of x is x squared minus 3, and I have to subtract x plus 4. Pardon me, on that one I absolutely want to use parentheses. Why? Yes, it reminds me to distribute, so I don't make that most common mistake made in mathematics, which is forgetting a negative. Well, that's not done. A couple things we can put together. What's the first term going to be? X squared, second term, and last term. When we did that problem in the blue over there, did we ever take an even root? Did we ever divide by anything? Domain's all reals. Domain is all reals. So that's what I wanted to get through here on day 1 of the review. That leaves us 13 through 20 for tomorrow. How are we doing for time? Ooh. Alrighty.